Welcome to JMR classes. Dear friends, today we are going to learn very interesting part of circles. Grade 9, session 3. Prove that cyclic parallelogram is a rectangle. In our last class, we have learned what is a cyclic quadrilateral. Cyclic quadrilateral is a quadrilateral whose vertices lies on a circle. Here, ABCD is a cyclic parallelogram. Why it is a cyclic parallelogram? Because its vertices A, B, C, D are lying on a circle. Then if ABCD is a parallelogram and if it is cyclic, then it must be a rectangle. We have to prove that. How can we prove? First of all, how a parallelogram will become a rectangle? Let us see. The interior angle of a parallelogram is 90 degrees. Then automatically all the interior angles will become 90 degrees. Then it is a rectangle. So we need to prove one of the interior angle A is 90 degrees. That's all. The proof is very simple. How can we prove it? Let us see. He has given ABCD is a parallelogram. The property of the parallelogram is opposite angles are equal. Therefore, angle A is equal to angle C. And he has also given that ABCD is a cyclic quadrilateral. The property of cyclic quadrilateral is angle, sum of the opposite angles is 180 degrees. That means angle A plus angle C is equal to 180 degrees. Now what I will do, in place of angle C, I will substitute angle A. Therefore, angle A plus angle A is equal to 180 degrees. That means 2 times angle A is 180 degrees. Therefore, angle A is 90 degrees. That means now we got the required condition. ABCD is a parallelogram. One of the angle is 90 degrees. If one of the interior angle is 90 degrees, all the interior angles also will become 90 degrees. Therefore, ABCD is a rectangle. I hope you enjoyed this problem. Shall we go further? Yes. Here, the diagonals of a cyclic quadrilateral are diameters of a circle through the vertices of the quadrilateral. Prove that quadrilateral is also a rectangle. How can we prove? Here he is speaking about the diagonals of a quadrilateral. What are the diagonals of the quadrilateral ABCD? AC and BD. This AC and BD are the diameters of the circle. What is the circle? Since ABCD is a cyclic quadrilateral, that circle is having these points A, B and CD. Now, if I want to prove that ABCD is a rectangle, first of all, let us prove it is a parallelogram. And if a parallelogram with equal diagonals is automatically a rectangle. So how can I prove it is ABCD is a parallelogram? For that purpose, I need to prove diagonals bisect each other. Diagonals of a parallelogram are bisecting each other. That means I need to prove OA is equal to OC, OB is equal to OD, AC is equal to BD. Let us see how we can prove it. OA is equal to OC. Why? Radii of the same circle. OB is equal to OD. The reason is the same, radii of the same circle. Therefore, ABCD is a parallelogram because diagonals bisect each other. And AC is equal to BD. Why? In the problem itself, he has given AC and BD are the diameters of the same circle. Diameters of the same circle are equal in length. Therefore, AC is equal to BD. That means ABCD is a parallelogram and 2 diagonals are equal. Therefore, ABCD is a rectangle. I hope you enjoyed this problem and it is very easy. Let us go for the third problem. Before going to the next problem, let us discuss a property. Let us assume here ABCD is a quadrilateral. Here the angle A and angle C are opposite angles. If angle A plus angle C is 180 degrees, then it must be a cyclic quadrilateral. This is the converse property of a cyclic quadrilateral. What is the property of cyclic quadrilateral is telling? If ABCD is cyclic, then sum of the opposite angles is 180 degrees. What is its converse? If sum of the opposite angles is 180 degrees, then ABCD is a cyclic. Using this converse property of the cyclic quadrilateral, we are going to solve some more problems. Are you ready? Yes, let us go further. The theorem goes like this. If the sum of the pair of opposite angles of a quadrilateral is 180 degrees, then that quadrilateral is cyclic. Let us go further. If the non-parallel sides of a trapezium are equal, prove that it is cyclic. I repeat, if the non-parallel sides of a trapezium are equal, prove that it is cyclic. Here, Trapezium means one pair of sides are parallel. Here AB parallel to CD. What are the non-parallel sides? AD and BC. If AD and BC are equal, then we have to prove the quadrilateral ABCD is cyclic. How can I prove it? First of all, let me take some construction. In order to prove this, I have to prove pair of opposite angles is 180 degrees. That means angle B plus angle D is equal to 180 degrees. How can I prove it? Let us see. Here, angle A plus angle D is equal to 180 degrees. Why? Because AB parallel to CD. Angle A and angle D are co-interior angles. If AD is transversal, that is the first condition. Now, what we will do, from D, we will drop a perpendicular, DE perpendicular to AB. And similarly, CF also perpendicular to AB. Let us draw these two lines. Afterwards, what happened? We got two right angle triangles. One is triangle DEA, another one is triangle CFB. In these two triangles, angle DEA is equal to angle CFB is equal to 90 degrees. Why? By construction. Just now by construction, we got 90 degrees. And AD is equal to CB. Why? He has given in the question, non-parallel sides are equal. And DE is equal to CF. Why DE and CF are equal? Perpendicular distance between two parallel lines is always same. Therefore, DE is equal to CF. By these three, what we can conclude? By RHS congruency, right angle, side, hypotenuse, I can say that these two triangles are congruent. Triangle DEA is congruent to triangle CFB. Since these two triangles are congruent, by CPCT, corresponding parts of congruent triangles are equal. Angle A is equal to angle B. This is my second equation. What is my first equation? Angle A plus angle D is equal to 180 degrees. Now what I got? Angle A is equal to angle B. Now in place of angle A, I can substitute angle B. Once I have substituted, I am going to get angle B plus angle D is equal to 180 degrees. That means a pair of opposite angles are equal. If a pair of opposite angles of this quadrilateral are equal, then definitely it is a cyclic. So ABCD is a cyclic trapezium. I hope you all might have understood this problem. Isn't it easy? Yes, very easy. By using RHS congruency, we can solve just like that. Shall we go further? This is a circle. What is this shaded part? Arc. What is the shaded part? These are all arcs. What do you mean by arc? Arc of a circle is nothing but the trace or the part of a circle in between 2 points. This is known as arc. All these are arcs. Arc is a part of circle. Now, how we will name the arc? Let us see. Here is point A. Here is point B. Let us assume this arc, blue color shaded arc, is called minor arc, small arc. This arc is known as major arc. But if I am coining it as AB arc AB, you will be confused whether I am speaking about minor arc or major arc. That's why I will take one point on the required arc and then I will call it as arc AXB. That means I am speaking about minor arc. Arc AYB. That means I am speaking about major arc. That means arc is named by using 3 points. All of you got how to mark an arc and how to name an arc? Let us go further. An angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Once again, I repeat, angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. Now, this is a circle with center O. Now, I want to take an arc. I have taken AB, one of the arc. This is the angle. So, angle AOB is the angle subtended by the arc AB at the center. This is double. That means 2 times to the angle subtended by the same arc at the circumference at the any part. I have taken one more point at any point, one more point. Angle is. So I need to prove 2 angle ACB. This is, dear students, this is very, very important theorem. Let us learn how to prove this theorem. Join OC and extend it up to D. Yeah. Have you understood how I have joined OC and extended up to D? Now, OA is equal to OC. Why? Because the radii of the same circle. And triangle OCA is an isosceles triangle. Therefore, angle OAC is equal to angle OCA. Have you understood? And angle AOD is the exterior angle. Exterior angle is equal to sum of the 2 opposite interior angles. But the 2 opposite interior angles are equal. Therefore, 2 angle OCA. Angle AOD is how much? 2 angle OCA. Similarly, angle BOD is equal to 2 angle OCB. Then what will be happen? By adding angle AOD and angle BOD, that means 2 angle OCA plus 2 angle OCB is equal to 2 times angle ACB, which is nothing but angle AOB is equal to twice angle ACB. That means angle made by an arc at the center is double to the angle made by the same arc at the circumference. Now let us do one more problem. Here, A, B, C are the 3 points on the circle with the center O. Angle BOC is 30 degrees. Angle AOB is 60 degrees. If D is any point on the circle other than arc ABC, find angle ADC. Now, first of all, find angle AOC. What is angle AOC, dear friends? 60 and 30. Sum of the 60 and 30. Angle AOC is equal to 2 angle ADC. If I want to find angle ADC, I need to know angle AOC. How can I find angle AOC? So angle AOC is nothing but sum of the angle AOB plus angle BOC. Therefore, that is nothing but 60 plus 30, 90 degrees. Therefore, angle ADC is equal to half of the 90 degrees, that is 45 degrees. I hope you might have understood, and it is very easy problem. What is angle ADC? 45 degrees. Very simple. By applying the previous theorem, we have solved it. Shall we go further? Yes. Now you see what a tricky problem it is. Here, in this figure, angle AOC is 135 degrees he has given. And he asked us to find angle BPC. He marked it as X. I want to find X. How can I do it? Very simple. Angle CPB or BPC, that is angle twice the angle X, is equal to angle COB. Why? Because previous theorem, angle made by an arc at the center is double to the angle made by the same arc at the circumference. So angle CPB is nothing but half of angle COB. If I am able to compute angle COB, I can find angle CPB very easily. But how can I calculate angle COB? Yes, AOB is a straight line. The straight angle is nothing but 180 degrees. So therefore, angle COB plus angle COA is equal to 180 degrees. Angle COB plus 135 is equal to 180 degrees. Angle COB is equal to 180 minus 135, 45 degrees. As soon as you got angle COB is 45 degrees, you can find angle CPB. What is angle CPB? Half of the 45 degrees, that is 22.5 degrees. Isn't it very easy? But looks complicated by seeing the figure. But once you have approached step by step, it is very, very easy. Here one linear pair logic, one circle arc theorem. So x is 22.5 degrees. Shall I go further? Yes, that's all for today, my dear friends. Let us meet in some other class. All the best. Happy learning.